Hi, ladies and gentlemen. We are looking at notes 5.1, which are on exploring equivalent trigonometric functions. I just want to get down some basic identities first, and then we'll derive some identities, and then we'll talk about some co-function identities. So today's lesson is going to be about all sorts of different identities that we need to know, and this is going to help us out for the rest of the unit. Okay, so our basic identities, what we have right here, this is stuff that you guys already know, the first three basic identities. So we know that cosecant of x is just simply 1 over sine of x. We also know that secant of x is 1 over cosine of x. And we know that cotangent of x is 1 over tangent of x, okay? But let's get a little bit more specific with tangent and cotangent. And we can also say that tangent of x is sine of x over cosine of x, and that cotangent of x is the inverse of this, so I can say it's cosine of x over tangent of x, okay? All right, so now remember right here, in our unit circle, when we have a triangle in our unit circle right here, we always have this is x and this is y, but really, essentially, what we really have is cosine of theta and then sine of theta right here. And we know that in our unit circle, our radius is 1. So we can say that cosine squared theta, using Pythagorean theorem, x squared plus y squared equals 1. So cosine squared theta plus sine squared theta is going to equal 1. Right? So that's one of our Pythagorean identities, which I believe you guys know from last year, okay? So then what if I were to do some playing around with some of these identities, right? So if I say cosine squared theta plus sine squared theta equals 1, what if I were to divide everything through by cosine squared theta? Well, now I know that cosine squared theta over cosine squared theta is 1. Sine squared theta over cosine squared theta right here is going to give me tan squared theta, right? Because sine over cosine is tangent. And then 1 over cosine squared theta is going to give me secant squared theta. So I can say 1 plus tan squared theta is equal to secant squared theta, okay? All right, and then if I were to do this again, take the original Pythagorean identity, cosine squared theta plus sine squared theta equals 1, and divide everything this time by sine squared theta instead, then I can say that this right here would give me cotan squared theta, and then this would give me 1, and this would give me cosecant squared theta. Okay, so that's another trig identity that I have that I can use to do some of the work that we're going to be doing throughout this unit. Now, one thing that I want you guys to be aware of is you can rewrite all of this stuff in any way you want. So for example, I could also say that cosine squared theta is equal to 1 minus sine squared theta. Or vice versa, I can say sine squared theta is equal to 1 minus cosine squared theta. So I can rearrange these identities however I want, but these are my three main Pythagorean identities, okay? Okay, so now we're going to take a look at co-function identities, and co-functions are just functions like, for example, sine, its co-function is cosine. Tangent, its co-function is cotangent. Secant, its co-function is cosecant. So there are relationships between sine and cosine, tangent and cotangent, secant and cosecant. So let's go ahead and explore some of these relationships. So the first thing I'm going to do is I'm going to draw a right triangle, because trigonometry is all based in right triangles. And I'm going to call this triangle right here, triangle A, B, C, right here, which means that this is little a right here, this is little b, and this is little c over here. And I'm going to call this angle right here angle theta, okay? Now, angle A and angle B will always add up to 90. So if this is theta, then I can call angle B pi over 2 minus theta, because it's 90 degrees minus theta right here. Okay, so one thing that I want you guys to realize is if I were to take the sine of theta, remember sine is opposite over hypotenuse. So the sine of theta would be equal to A over C, right? And if I were to take the cosine, or if I were to look at pi over 2 minus theta, What is going to give me A over C? Well, it's adjacent over hypotenuse. So I can conclude that the cosine of pi over 2 minus theta is also equal to A over C. Therefore, sine of theta is equal to cosine of pi over 2 minus theta. That's a conclusion I can make all the time, okay? All right, so now let's try another one right here. If I were to take the cosine of theta, remember cosine of theta is adjacent over hypotenuse, so I would get B over C. If I were to look at this angle up here, what gives me B over C? It would be the sine. So this time the sine of pi over 2 minus theta is also going to give me B over C. So I can say cosine of theta is equal to sine of pi over 2 minus theta. Okay? All right, so now let's try another one right here. If I were to do the tangent of theta right here, so if I want to look at the tangent of theta, the tangent is going to be opposite over adjacent, so that's going to be A over B. Well, right here, when I look at this angle up here, the cofunction of tangent is cotangent, so I can say the cotangent of pi over 2 minus theta. And remember, cotangent is going to be the opposite. So instead of opposite over adjacent, it's going to be adjacent over opposite. So it's going to be A over B as well. So I can also conclude that the tangent of theta is equal to the cotangent of pi over 2 minus theta. And let's go ahead and verify this graphically to see if these statements are really true. So our first conclusion is that sine of theta is equal to cosine of pi over 2 minus theta. So I'm going to graph out y equals sine of x right here. And then I'm going to graph out y equals cosine of x. And if you remember, in order for me to be able to get this blue to line up with this red, I have to shift it over to the right by pi over 2. So let's see what would happen right here. So cosine of pi over 2 minus x, they line up exactly with each other, so it works for us, okay? So then the next one that we have is y equals cosine of theta. So let's see, y equals cosine of x. Let's see if sine of pi over 2 minus x will match up, and it does. So those are going to be true all the time as well, okay? Let's do one more. If I were to do y equals tangent of x, and then take y equals cotangent of pi over 2 minus x, they will also line up with each other. So these three statements are true all the time. Okay, so these are some identities because they hold true all the time. Okay. Okay, so if I want to write out all of this information in a summary, I can just rewrite right here that we know that sine of theta is going to be equal to the cosine of pi over 2 minus theta. We can say that the cosine of theta is going to be equal to pi over 2 minus theta. And then we can say that the tangent of theta is equal to the cotangent of pi over 2 minus theta. Okay, so now the same statements will hold true for my reciprocal functions, okay? So I can say that the cosecant of theta is equal to the secant of pi over 2 minus theta. I can also say that the secant of theta is equal to the cosecant of pi over 2 minus theta. And the same reasoning applies for these guys right here as what we did up here. I'm just not going to go over every single one, okay? And then we can also say that the cotangent of theta is equal to the tangent of theta, or sorry, the tangent of pi over 2 minus theta, okay? So now we're going to look at equivalent expressions from symmetry, and we're going to take a look at this from two different perspectives, from the unit circle perspective as well as from a graphical perspective. But I just want to remind you, for symmetry, we either have odd, or even, or neither, right? And if a function is odd, then we can say that f of negative x is equal to negative f of x. Okay, this is something we learned way back at the beginning of the semester, okay? And if a function is even, then that means that f of negative x is going to equal f of x. And basically what this statement is saying, excuse me, is that you're reflecting in the origin. And what this statement is saying is you're reflecting over the y-axis. Okay, so let's go ahead and take a look at cosine of theta using the unit circle. So if I were to look at the unit circle right here, when I look at it, if I have a triangle right here, this angle inside of here is angle theta. Okay, so let me just draw this a little bit bigger so you can see it a little bit better. So right here, this is angle theta inside of here. So now if I want to figure out cosine of theta, or cosine of negative theta, what's that going to be equal to? Well, when I draw in negative theta right here, it's going to be the exact same triangle, but it's reflected over the x-axis. And this is different than this reflection right here, because we're talking about the actual graphs of the functions versus the unit circle. But if I look at my x value, because that's what cosine is, my x value stays exactly the same, so nothing's changed. So I can say that cosine of negative theta is equal to cosine of theta. Okay, so that's my symmetry expression, saying that cosine of negative theta is going to be the exact same thing as cosine of theta always. Okay, now let's take a look at it graphically. Remember, cosine of theta, when I look at it, it starts at 1 and then it ends up looking like this, correct? And then if I were to extend it the other way, this is how cosine of theta looks on both sides. Well, if this is what cosine of theta looks like on both sides, I can reflect it in the origin, or sorry, excuse me, in over the y-axis, and it looks exactly the same. So cosine of theta is an even function, so therefore my expression from symmetry is that cosine of negative theta is equal to cosine of theta. Okay, so now let's look at the sine of theta in terms of the unit circle as well. So I want to know what's going to happen if I take the sine of negative theta. Okay, so right here, same thing. Here's my triangle, here's my theta. Okay, if I were to draw the same triangle right here and use negative theta instead, my y value up here and my y value down here are going to be opposite signs of each other. So I can say that sine of negative theta is negative sine of theta, which means that we have an odd results. Okay, so let's look at it. Let's verify this graphically and see if I really do end up getting an odd result when I have sine of theta. So remember, sine of theta ends up looking like this right here. So when I were to, and pretend like it's symmetrical, if I were to reflect this over the origin right here, then each value that I have like up here will reflect through to the value over here. So therefore it's going to be an odd function. So we can say that sine of negative theta is equal to negative sine of theta. Okay, so now let's take a look at what would happen if we have tangent of theta. So if we remember again in our unit circle right here, if we were to look at our unit circle and draw in our triangle that we have here and take a look at what happens right here, this is our theta, and then right here we've got y and we've got x, and tangent is y over x. When I look over here, this is negative theta over here, and this is negative y over x. So they're opposite signs of each other. So I can say right here that the tangent of negative theta is going to equal negative tangent of theta, and that's an important identity to remember as well. So now let's take a look at our graph of what this would look like. So if you remember, tangent of theta ends up looking like this right here, and this is definitely going to be odd because when you reflect it in the origin, it looks exactly the same. So these three identities here are key. We're going to verify these three identities right now graphically to make sure that these statements are really true. So if I were to graph out cosine of negative theta, let's see what ends up happening. So cosine, y equals cosine of negative x. And then I'm going to graph out y equals cosine of x. And if you notice, they totally line up with each other. They're exactly the same graphs as each other, okay? So now, what if I were to do y equals sine of negative x, and then I were to look at y equals sine of x? So if you notice right here, they're reflections of each other in the x-axis right here, which means that when one value is positive, the other one is negative. Therefore, I can say that y is equal to negative sine of x, and that will correspond with my red graph that we originally had up here. Okay, so now let's do the same thing for tangent right here. Oh, sorry. So we're going to x out of that, x out of that. We'll say y equals tangent of x right here. And if I were to do y equals tangent of negative x, they are going to be opposites of each other. So all my positive y values will now have negative y values. They're going to be the opposite values. So we can say y equals negative tangent of x, and that's going to line up with our originally black graph right here. And that means that tangent of negative x is equivalent to negative tangent of x. Okay? All right, this next piece we're just going to kind of discuss together. Make sure you pay really close attention to understand what I'm talking about. Don't zone out. So it says explain how you can tell from this diagram of a unit circle as well as the graphs that sine of pi minus theta is equal to sine of theta. So if you look right here, this angle up here is theta. That's my angle that I'm looking at. And when I look at sine right here, my sine is the y value, right? Because the radius is 1. So if sine of theta is y over r, it's really y over 1 or just y, okay? So if I look at this angle right here, this is theta. This angle right here is pi minus theta, because in order for me to get to this angle over here, I have to take all of pi and subtract this little theta from here. Okay, so that results in the triangle that's shown to me over here. This triangle over here is the triangle that we're looking at that's pi minus theta. And if this is y, this y value right here is exactly the same, so they haven't changed signs at all, because you remember in the first and the second quadrants, sine is always positive. So sine of pi minus theta is going to equal sine of theta. Okay, now remember cosine of theta right here. If I were to look at cosine of theta, remember cosine is x over r. It's my x value right here, my adjacent over the radius. Well, my radius is 1, so it's x over 1 or just x. So if I were to look at x over here, in my new triangle, my x value is the opposite sign. So it's the same number, but they're negations of each other. So I can say that it's negative cosine of theta, okay? And then similarly, if tangent, sorry about that, if tangent right here is going to be y over x, then right here my tangent is going to be y over negative x. So tangent of pi minus theta would be negative tangent of theta. Okay? So I'm going to get you guys started for the remaining identities, but I want you to see if you can figure these out yourselves. So if I were to do sine of pi plus theta right here, this time when I look at my unit circle right here, I know that this is still going to be my theta over here. But this time, let me draw it a little bit bigger again so you guys can see it. Sorry about that. So right here, this is going to be my theta inside of here. This time, if I'm doing pi plus theta, that brings my triangle over here into the third quadrant right here. And this is still theta right here, but all the way around is going to be pi plus theta. So the question is, what is going to happen to my sine value? So sine of pi plus theta right here, if my sine value is y right here, this is negative y right here. So I can say that this is negative sine of theta. Okay, I want you to figure out the remaining 5 identities here, and then we'll discuss it together as a class. But I want to verify the first 3 that we have up here using Desmos, or the first 3 that we have on the side over here using Desmos, just to make sure that those identities really hold true. So the first identity that we have right here is that the sine of pi minus theta is going to be equal to the sine of theta. And that's true. They overlap with each other, so that is true. Okay? So now I want to do the cosine of pi minus theta and cosine of x right here. And they don't, excuse me, they don't overlap with each other, but if I were to make this the negation of it, then they overlap with each other, so it works. Okay, one last one, the tangent of pi minus theta. I want to put tangent of theta over here. They don't overlap with each other, but if I put a negative in front right here, it does work. So I can say it's the negative tangent of theta. So my statements all hold true. So I want you to please determine the remaining 5 statements here and then verify with it graphically, and then we'll talk to each other and take this up next time I see you guys in class. Okay? Have a great day.